Hey, how's it going, everyone? Welcome to the stream. All right, so let me get right into where we were last time. So last time I streamed, we did quite a few cool things. Let me see if I can get this on screen. Yeah, so let me bring up this guy here. So here we go. We start up the debugger from VS Code. That opens up Vectrexy. I need to attach to it right now. Now, once attached, we should hit a breakpoint at the beginning of main of Vectrex Pong here. There we go. And from here, we currently support step into, right? So, and the main thing we worked on was right here, the call stack, right? So I think it's F11. So you can see here, I'm going to step into the BIOS init. Right now, we're only showing the address of the functions that we are in, but we do show the file name and line number correctly, along with the column number. So if I keep F11ing in, you can see here, we keep going in there. So now I can click here and this shows where we were when we entered that function. So that's basically what we worked on. In fact, let me just pull this up here. I think I never actually committed the changes we worked on, but let me just take a look here. We'll probably do that. Yeah, we did a lot of stuff. Oh yes, it's because I just need to clean up some of this stuff. But there's the stack trace response, which is basically what we got here. And we factored out all the call stack stuff. That's right. So it was mainly about working on the call stack. Parsing out function names. I don't think we did that yet, so this is not going to go in there. Don't need that. Don't need that. Don't need this. Okay. So that's what we did. And we can basically keep going. So what's next is what I would like to do here is I'd like to actually show function names, right? Now last time I talked about this. I talked about how the reason why we're not showing function names is I need to actually parse those names out of the RST file. And I had mentioned that the names that we get out of the RST file are mangled names. So let me show you what I mean. I just bring up this guy here. I have my notes. No, it's not here. Too many files now. Where did I keep my notes again? Oh no, yeah, it is here. Okay. So yeah, so this is my to-do list. So we were working on show the call stack. We got this part done. Integrate call stack tracking code. And we did display call stack as function name when available. So let's just say the display call stack as address. We did that. And then the next one is display call stack as function names. Okay, here I put addresses as function names when available or address otherwise. So that's the next part. Now to do that, we actually need to do this. Add symbols for function names. Now the stabs file, this is an example of the line that we're going to have to parse. This here maps to the symbol of the label in the same stabs file, so like the assembly label. And then over here, the very first string here, that's in quotes, this contains the mangled C++ or C name for the function. And what we did last stream is I just took this name and I copy pasted it into some online, GCC function demangler, and it produced the correct name here. And so I thought, okay, that's cool. I definitely want to be showing the demangled name, and I thought this shouldn't be too hard. I'm sure I can find a library online that can help me do that. So as it turns out, it's not that easy. And the reason for that is very simple. The way the name mangling scheme is not something that's like it's not like a standard. It's proprietary. It's specific or implementation specific. So each compiler can decide to mangle as they like. Now, in truth, most compilers kind of do the same thing, although I think there are some differences with MSVC and GCC. GCC Clang, I think, do the exact same thing. But the thing is that the best library to demangle a name is part of GCC, for example. In my case, I care only about GCC since I'm using GCC to compile, so I'm getting their mangled names. I guess I could use Clang, but the point is that the way to demangle this is to use a library that comes with GCC, and that exists. There is actually like if you have GCC, the source code somewhere, you can include some include path in there and include a specific header, and as long as you've compiled enough of the libraries, you should be able to demangle, except that I need this to work on Windows and on Mac, I suppose, eventually. So the thing is, on Windows, I can't use this GCC specific library because it makes use of utilities that are only available on Linux. So all that to say is I was like, well, what do I do now? I mean, I literally looked a long time, and I thought surely someone must have tried to write one that doesn't require GCC, just some kind of name demangling library with a, following the spec. And there is a spec online. Just try and write, like I could do it. Like I could spend time to write a demangling thing. But you know what? It turns out it's actually pretty complicated. There are lots of corner cases. It's a lot of work. And most people just say, you know what? I'm not going to waste my time. If I need it, I'll just use the one from GCC. I think MSVC offers its own API. Well, anyway, so that kind of sucks, right? So then I thought, what else could I do? And then I realized another way I could do this. And that other way is, once I've compiled the program and I've produced these RST files, what if I took those RST files and, used a utility in Linux, because I am using Docker and all of this is expected to be run in a Linux environment, right? So if I can use some utility to go ahead and demangle these names in place in the file, then I would end up with a file that has these kinds of lines in them. So with already demangled names, right? And my code basically would just parse out exactly what's inside the quotes. Mangled or demangled, it doesn't really matter. I would just show that. But if they happen to be demangled, great. So there is such a tool. It's called C++ FILT, so C++ FILT, like this. See, it's a GNU binary utility. And you basically just give it a symbol and it'll output the thing. So I'm going to show you what that looks like actually. All right, so here I'm using my GCC 6809 Docker image. Let me actually increase the font size a bit because I think it's, hopefully that's, go a little bit more. Okay, there we go. So yeah, so let me do that. In fact, maybe I'll remove some of this. I realize it might not be so clear on stream, so I'm just going to make it a little bit darker here. Where is that again? Oh, here it is, opacity. Okay, there we go. So this is the Docker image that I created that we basically invoke every time I want to build, say, Vectrex Pong, my Vectrex game. I have in here, this Docker image contains the compiled tool chain. It calls GCC 6809, it compiles, and I have a make file and it does a bunch of stuff. But basically, if I'm here, if I type C++ filter, you'll see that it's waiting for something. I think I can actually paste this in there. Oh, maybe paste it properly. There we go. So you see if I paste it and I hit enter, it demangles the name, right? And the thing is that you can actually put a whole bunch of stuff and it'll only demangle the part. So I just pasted and it went and maybe that was a bad example. Anyway, the point is that it does the demangling, right? So what I did then is I said, okay, cool. What I can do is in my, where is it? Here. I'll stop the debugger here. So in the make file, here we go. So this is the make file that I adapted from an existing one. In there, I collect, like at the point where we generate the RST files, which happens at this step here. Is it here? No, sorry, it's here. So here, when we do linking of all the .o files, we create what's called an S19 and an underscore ram.s19, so these two files. But at the same time, it also generates a map file and all the RST files, one for each .o. And so after that's done, I added basically this here. So what I do is I go through all the RST files and I cat the output of that into C++ filter, which is that filter. And then I pipe that into sponge, and this 2 is not supposed to be here. So with this in place, oh yeah, I think I put the 2 because I wanted to show the difference. Yeah, that's it. With this in place, let's say I decide to build here, like that. All right. So say we build it like this, and we go here to the folder. So here's Vectrex Pong, right? So in this folder, you will see that we have these RST files. Sorry, this is a little confusing here. Why don't I see my RST2 files? Try something, just clean first. Okay, so clean worked. And now I'm gonna do run task make. All right, so there is all the 2 files. Why am I not seeing these files? Sponge main.rst2. That's funny. This was working last night or 2 nights ago when I tried it. Let's see, cat. Let's try it by hand. So if we go into here, I think I need to mount. Hold on a second. Okay. Let's mess around with this stuff here. Okay, so what we're trying to do is we're trying to say cat main.rst to, so if I just do this, C++ filter. So there you go. So there's an example of it actually applying correctly. Now, what we're doing then is we're saying take that and sponge it. So sponge is a utility that allows you to take any, like all of, say sponges, it sponges out in all of the stood out and then can write it to a file. The problem is that what I want to do is I would like to, take this and do this here. But you can't really do that because while it's reading from the stream, it can't be outputting to the same one. So one of the solutions is to pipe it to sponge and then write, say, main.rst like this. And then that would actually do the thing. Oh, sponge. Whoops. Sponge like that. Ah. Sponge command not found. That's why it's not working. That's odd. I added it. That's super weird. I just updated my Docker image. Well, okay, so I'm not going to waste time on that, but basically you're supposed to install binutils, which is something I just added to my Docker file, and I don't know why it's not there. Oh, it's already installed. So why isn't Sponge there? Hold on, give me a second. Am I getting this right? So Linux Sponge. Oh, it's from more utils. Why didn't I have that in my changes? That's odd. Oh, I see. Okay. I think I was trying something and then I removed it. So say we have more utils in there. I'm gonna have to add that here to my Docker image here. I'll take care of that later. So say it's there. So now if we do this kind of sponging that we're talking about, okay, so now it should have worked. And there's my main RST2. Still confused as to why I lost that. Very strange. If I compare, you'll see that everywhere we have the mangled names, we now have the proper unmangled name. And what's cool is that it doesn't affect the labels. You know, there's an extra underscore there. It knows that that is a label that's not, you know, it doesn't do like some kind of substring match and then take this and accidentally demangle it. It only demangles, you know, the entire thing. So it's pretty smart about it, right? I find that that's great, because I was a bit worried about it not working the way I expect. But here's another example where it's doing the right thing. So all of these now have been replaced. So with that in place, we should totally get, you know, the demangled names on the call stack. Which I think is pretty awesome. Okay, so a little unfortunate that I didn't get that properly working on the first shot, and actually now when I exit from here, this Docker image is closed and no longer has that change. So what we'll do now is we'll work on getting those names in. They'll be mangled, and that's okay. And then after that, I'll update the Docker image and everything should be fine. So yeah. Let's just do another clean here and another make. I want to get all these files with the mangled names in there. All right, cool. So let's get back to it. I think I'm going to commit what I have as well. Say call stack. Let's see here. This looks good. DAP debugger.h. Debugger util, yes. This I'm going to modify a little bit. Let me look at the diffs here. Yeah, that's it. That's what I wanted to get rid of. All right, so here's where we're creating our response. This is the code we added last time. Yes, yes, yes. Okay, good. Put that in there. Okay, don't need to put this yet. Neither that, nor this, nor this. Okay. Okay, so what do I say for this change? So I'll put DAP debugger show call stack. How about that? Show call stack with function addresses, which is basically what we did. And I'll just say here, factored out call stack code from debugger into debugger util to use in DAP debugger. All right, good. So that's done. All right. Basically, what we want to do now is this part, right? Is display call stack as function names available or address otherwise. So let's do that. So in order to do this, we're going to want to parse the stabs file again. So let me make that open here. Main.rst. It's not deleted. Main.rst. And the stabs file that we're looking for is (36). No, sorry, (36). So it's all of these guys here. And what we read last time is that when parsing, we're going to see the labels before we see this line here. So we're going to want to collect labels and store the addresses that go with them. And then when we see one of these lines, we're going to look up that label, get its address. Do we need the address? We do. And we need to store this information. So I think I thought about this already. Yeah, it's exactly what I wrote here. Okay. Oh yeah, that's it. Store labels we see along the way in a local map. When we see an endfun stabs, look for it in the labels to get its address, then add a function info to debug symbols. Ah, that's right. I wanted to be able to add a lookup for functions by address. Because when we're populating the call stack, yeah, so the stack trace here, what we want to do is we would like to replace the name, I suppose, was it? Let me see here. Yeah, this name here. Look up function name of frame address. So that's it. So by address, we want to get a function information, right? Just thinking if I need more than just the name. All right, so something like this. We'll start by doing what I said here. I am starting to wonder whether or not I'm going to be able to keep the state machine. Parse directives, parse line instructions. Because when I'm doing parse line instructions, let me see here. So parse directive. So I'm looking for main, I'm looking for stabs. What's this again? Stab string directive. Okay, that's right. It's probably going to be in here. Else, if it's a stab dot directive, then I do this. So in our case, when we hit a stab dot directive, like this one, that's the thing, you see, because there are labels inside there as well. But maybe I don't care about those labels. Let me see. If I pay attention to the labels that go with here, like basically function labels are not part of parsing instructions. Stab D, and then what gets me out again of the stab D is when, so while we match an instruction, we keep doing it. If we instead match just a regular stab, okay, that's it. The moment we hit another stab, we're done. So stab D, we start parsing instructions until we hit another stab directive. So even though there are labels in there, I'm not sure I care about those labels. I care really only about the labels that are used for specifying functions. So I think that I can actually keep it this way. And honestly, I'm thinking I also need some more comments here because this is not super easy to understand. Something like, yeah, if matching, if match, if stab string, if stab dot, I think that's what it stands for, right? Directive. Stab string. Directive. Now here, while we match instructions, collect source locations while we match instruction lines. Stop as soon as we hit a stab directive. Hit any stab directive. Okay. So I think this means that all I really need to do is, just like how we're checking over here, we have name of include file over here for when we hit a stab string directive. We're going to hit a stab string directive also for function name. But we have to make sure to collect labels. So let's do both of these. And like I said, the labels will be during the parsing for directives. All right, so let's write a regex for labels. So label RE excuse me. All right, so how are we going to match this? We've got I suppose it always is. There's always like some tokens, then we get some white space followed by the label, followed by a colon and a new line. End of line. I think that's how we're going to do this. So we're going to say dot star followed by at least one white space and not 0, right? Because we should have some tokens before it. And then we're going to capture the label followed by a colon $. Yeah. Match a label line. Yeah, so while we are parsing directives, I guess it doesn't matter where I put it. This looks for main. If main symbol. So actually, that's the thing, right? I guess when I look for main, I'm actually looking for a symbol line. So maybe I should reuse this. What did I do here for main? Yeah, this is very much the same thing, right? Maybe I could do, like, I can combine this. Say if it's a label and specifically if it's main. I think that would make a lot of sense. Yeah, totally. So let's do that. So what did I do here? I just did space. So any number of white space. Really? That's a strange. Oh, okay. I see. I was really specific about capturing tokens, like an address. Oh, because I want the address, and actually I need the address. That's true. Yeah, okay. So actually I'm going to totally steal this. And I will add the $, just to make it clear. And I'm going to capture here this part as well. Because before we were only capturing the address and not main, but now we want to capture address and the label name itself. I should probably say this, captures, label, address, label. I should probably do that for all of them. Okay. If label line. So it's address. So here we'll say label match of 2. If label equals to underscore main, we'll do this. If it's main, store that as a special symbol. Yeah, because that's what I was doing here. As I have this add symbol, sort of generic add symbol, and then I have this get symbol by name. Yeah, okay, that's fine. So, sorry. Add the main function symbol. And otherwise, what we want to do is we would like a vector of addresses. What is it? No, we want a map, I suppose. Not hash map, unordered map. That maps addresses to, no, what do I want? Yes. No, sorry, I want label name to address. So label to address. And in fact, do I need to keep this? Yes, I need to keep this alive. So normally I would put this in my state, but yeah, it's getting kind of getting annoying. Okay, I'll leave it up here. Should turn off my phone. Excuse me. Okay. I always forget what the new way to insert things is. I could just do this and say okay, so let's see if this builds. Does indeed. I don't need this anymore. So now we have that. And right. And then as we're parsing these guys here, okay, if include file name, yeah, they call it include file, but basically if source file name and then otherwise we'll say if function name. So for the stabs directive, let me go here. No, sorry, not the stab string. Let me write what we capture. Right, because a string has multiple sections. I should have named these. Let me see here. Okay, here we go. This is what I want to see. So the string itself, 2 is the type, 3 is called other, and 4 is description, and 5 is value. Right? 1, 2, 3, 4, 5. It says 1, 2, 3, 4, and 5. Yeah, great. So we want to check the type. So if type is that, if type is n underscore function, now, if it's a function name, we want to find the label. We should find the label for it, right? So what we want then is, so we know that the string, the quoted string here, which did we capture including the, no, we don't, good, we don't actually include the quotes in our capture. That's great. We do have that little colon F something that I might want to capture separately, but I'll worry about that afterwards. Okay, so that's the string. We want to get the value. That's right. The last one. So the value in this case is the label. I guess I'll call it value. Let's match a 5. Label name. So now we say label to address dot find value. Yeah, so what do I do if we have an error, you know? I guess I should just report it and keep going, because if somebody manipulates this file, I don't have full control over it, right? So if it's equal to end, I guess, because the thing is I can't log, well no, I guess I could log error f, and I'll just say, I don't know if even if it's considered an error. I guess I'll do this, printf warning, maybe I'll need a warnf actually. Label not found. All right, so say we do find it, then what we want to do is we want to add this to our debug symbols. Add function, let's do that. So start iter is going to be the address. I guess I want to store the name itself as well. Oh yeah, and we need the name, right? The friendly name or whatever we want to call it. But we're just going to call it name. So we've got value here. And what did we call it? The string. Oh yeah, I can't really call it string though. Right? Well, maybe I can. Mangled or unmangled. Maybe mangled. Okay, let's do that. You know what? Function name, label. It's just too confusing otherwise. Func address. Star iter, and this we need to stud twi it, and in fact I think I'm going to need to do my little helper function because it's going to be, oh yeah, hold on a second, oh I already did it, oh yeah, so this, what am I doing, this is already in the right form. So that's good. So here we're going to want to add, I don't know if I should store it a label name. I don't think it's useful. I think all we're going to want to store for a function is, I'm still thinking here. I'm going to be looking it up by address. That's for sure. So maybe I'll just do something like this. Func name, func address. Debug symbols. Yeah, I'm really struggling here to think about, maybe I should just be adding it as a symbol. Because a symbol has a name and has an address, right? Isn't that pretty much what I want? It would seem so. I could have get symbol by name, get symbol by address. I don't know if I need to like separate out my symbols like from functions or non-functions. In the end, they're all the same thing. It's just a name. I don't think I need anything else. Yeah, let's try that. Oh yeah, that's right. This returns a pair. Okay, so in that case, I think I'm going to have to change my debug symbols here and call this like get symbol by name. So where do I call this again? The DAP debugger here. Let's try this. 16 T address. Okay, so let's add maps in both directions. So basically, or not both, yeah, like this. I need to find a better way to do this, because now I'm going to be copying symbols everywhere. All right, well, for now, that's what I'll do. Symbol. All right, it's gonna look very similar to this guy. There we go. Okay, so if all went well, we will have parsed out and added symbols. So let's see what this looks like. We'll put a breakpoint here. Build. Oh, and actually fix compilation errors. Okay, where's my actual error? Ah, typical. Oh. What? I was trying to pass a string to printf. Okay, there we go. So let's go back to VS Code here, hit F5. It's running, let's attach. Hopefully this works. What? What just happened? Why is it not playing? That was weird. Try again, hit F5. Okay, so here we are. What is the BIOS ROM here? We have a ROM, Vectrex Pong, that looks right. Init. Oh, failed to load. Why? Oh, yeah. Oh, I think I know what's happening. Because my make file is failing due to that sponge not being there, it's actually aborting the make. Yeah, that's not good. And the thing is, I don't even know about it, do I? Oh, here you go. Sponge not found. Recipe failed. Yeah, if I just paid attention to the output, I would know. I would know what's going on. So, all right, let's just remove this for now. Oops. Remove this. And yeah, let's build it. Now this should build correctly. There we go. There's our vec file. So let's try this again. Hit F5. Attach. Okay, so now we should be okay in here. Yeah, so let's hit F5. Oh, something went wrong. Debug assertion. Okay, let's see. So I'm doing something bad here. Oh, right. I'm supposed to continue here, not keep dropping down. So that's wrong. But what is this? Empty label for, okay, so clearly I have a mistake. So let's put some breakpoints right in here. All right, so what do I do if we hit that warning? We return? I guess we return. Yeah, because this is a function, so we can just return. All right, let's hit no, not hit F5, actually. Oh, could I? Could I just hit F5? I suppose I could. There's no need for me to debug it through VS Code. Yeah, there we go. Although I got to make sure to actually run it with DAP. Hold on a second. Debug and launch settings. Here we go. Dash DAP. Okay. So this is a label. We've matched it. Let's get our address. That looks fine. And what's our label look like? Empty. So that doesn't look good. So did I put the wrong thing? Yeah, we should have captured L text here, but we did not. Oh, no. No, that's fine. Does it not like my end of line? Let me go see. So this is what was L text. So So take out the match here, match L text 0. Looks like a line like this. Yeah, should have matched end of line. Let me see. Match label line. Space, 0 more. Match the address. Then match 1 or more spaces. Then a bunch of tokens. Oh, yeah. That's not really going to work, is it? That's just going to eat up the L text here. I need to say a bunch of tokens followed by a space. I don't know if I should say exactly 1. I guess it's always 1, but I should say at least 1 or more. And then I can get my token. All right, let's try that. Regular expressions. Oh, we love them. See our match. And there we go, L text 0. So we have something. So now, you know what? I'll just put a breakpoint here. Oh, okay, there we go. So function name is memcopy f1. So that colon f1 will take care of it later, but it's fine. The label is underscore memcopy. So we look for it and we find it. And so now we have it, then the label with its address. We want only the address. So that's 468. So like if we look in here for underscore memcopy, is that right? Okay, sorry, this is 07. Oh yeah, because we're not in hex. That's right. 468 hex. $1D4. That's not at all what I was expecting. Are we parsing the same file? Oh, base.rst. Maybe that's why. Does that mean that they would have different addresses? And look at that. 1D4. I guess memcopy will live at different addresses then. That's kind of weird. Well, yeah. Right. Yeah, that's going to be confusing, isn't it? So I was thinking about how basically this comes from a header file. So each CPP has its own copy of it, right? See, the code's exactly the same. Huh. Yeah, that's not great. Do we have any information as to what, oops. Maybe the map file contains it. Nope. Okay, so that's somewhat surprising. And the reason why I'm surprised is that in the makefile, when we do this command here, the link command, the option that we pass here is update listing files with link data as files, RST. So this is what produces the RST. Apparently it outputs the link data. So I thought that what that meant was that it would, show the right addresses for one definition rule symbols. So symbols that are, let's say, come from a header, each CPP has its own view of it, but the linker is supposed to resolve all that and produce, the one address that it gave to it. But in this case, that's not what we're seeing in the RST file. So maybe it's just something I misunderstand here, but like my question now is, are there really 2 copies of this in the final binary at these 2 addresses? That would be kind of sucky, right? And maybe this is because I'm building without optimizations. And if I were to build with -02 and still use -G, we might actually see something more sensible here. I guess I could find out. Just do a little quick check. So I'll do -02. Yeah, it's not smart enough to know that I have to clean it. Okay, clean. Oh, right, I'm in the process of holding a lock on a file. Whoops. Okay, so let's go take a look now. So in here, in base.rst, memcopy, it's not even there. No memcopy. Main is still there. Okay, so let's say this symbol. Oh, see, it doesn't even exist. So maybe that's it. The symbol doesn't exist because it's in another file. Does that mean then, or it inlined the function? So like this one here, this is a function. This function now will be externed. I think memcopy got inlined. That's probably what happened. That would make sense. So yeah, maybe it is the case that we end up with multiple copies. And if that's true, then I'm going to have symbols with the same name with multiple addresses. That's not great. This means that when I'm adding those symbols, right now I'm doing this mapping because I assume a one-to-one mapping, a unique mapping of name to symbol, symbol to name, and that's not true. So what it means is I might need a multi-map. if I actually have to find addresses from names. Right now I only need the address from name for the main function. If I only store address to symbol, I could do a linear lookup for main just for that one thing. It's just once. And maybe I don't ever need to look up symbols by name. Yeah, let's try that. So we remove symbols by name. And now here's the hitch. We might find, find the first symbol with the input name. There may be more than one. No? Oops. So if I found it, then that means we have our iterator here. This is our const iterator. Why can't I do this? Stood pair. All right, it's a stood pair. Right. What I want to do is I want to return the what? The second. Yes. That's right, like this. It's very confusing. Okay. Good, good. Nobody good here? Const symbol. Oh, right. Does that work? Am I getting the actual one in the map here? Is this a reference? This does not look like a reference. I need a stood pair reference here. Not reference. Can I do this yet? Okay, and then here we can say if address, no, if symbol dot name, and then return address of symbol. Okay, there we go. That's what we want. Otherwise, return empty. All right, so we do a linear search like this. All right, back to this. Okay, let's build that. Okay, it looks like it works. Let's hit F5. I don't even remember why I stopped here. What was I doing? Function name and labels. Is this right? Okay, so there's our A function name. There's a label. We find it. We get its address. Oh yes, I was looking at the address. I was surprised at the address. Now I didn't hit the same thing because we built with -O2. So let's go back to what we had before. O0. Let's clean and then make. Okay, looking good. So we were looking at base. I think we're going to get memcopy, right? And that's the address. Oh yeah, so yeah, it was fine. Because that was the address we were expecting for that symbol. Okay, so function name is memcopy, and function address is 1D4, which is 01D4 over here. We add that as a symbol, and we just keep parsing, and eventually it takes forever. All right, so here we are. We just finished parsing one file. We parsed base. Let's take a look at our symbols, our debug symbols. So we have 11, and here they are. I'm going to just say hexadecimal display. So you see memcopy, string length, and we have some Vectrexy print. All of these names are currently mangled, very difficult to read, but there they are. I am going to want to cut off that little type name at the end. And I'm pretty sure it's always going to be the last 3 characters, because that comes from the stabs format thing that was describing that specific field. I don't even remember where I saw it, but basically it's yeah, it's part of the procedures, I think. We go to contents, procedures. Here we go. And it said something about capital F and small f. Here it is. A function is represented by an F symbol descriptor for a global or extern function and a small f for a static or local function. So you see how memcopy has a small f? In fact, they all have no, they don't all have one. This one here, assert handler, somehow is considered global. Then all the other ones are considered local. And actually these symbols here don't have an F, they have an S with 2 numbers. Default intensity. What's that about? Whoops. Find here we go. So what's this? Huh. Okay. It's just some label. It looks like it's labeled for... It is a function. Default intensity, because it's a 36 here. But it's not really a function, is it? It just has a value. Why does it consider this a function? Comma 36. Default intensity. So let me go back to my code. Yeah, so it's just a constant. Constant. So both default intensity and default scale appear here with comma 36. Which is supposed to be for functions. Odd. So what does that mean? Maybe the S here is part of it. All of the following stabs normally use the nfun symbol type. However, okay. So a function is represented by an F symbol descriptor and an F first line. So maybe I do need to look at that. For a.out, and maybe like S stands for static or something like that, you know? Whoops. In this case, it's constant, so, you know, static. Maybe that's what that's about. C function name or text segment variable. There we go. This might be useful. Global function, local function. So it goes proc name colon hash return type. Okay, so that's either F or F, but that's not 36 and fun. C function name or text segment variable. So here it says text segment variable, but then when you go look at its description, it only shows the case for F and F. Oh, for text segment variables, how to create one. Okay, so this is not very complete. Let's see if I can find something better. Looks like Google Books has something on Mac OS X about it. 2006. Okay, I'm not going to worry too much about it. I'm pretty sure that what this is telling me is we're going to want to look at this value to be sure that it's a function. The type itself is not enough, but I'm actually not going to worry too much about it right now because I don't really care that I've collected extra symbols. It's not gonna, I'm not going to reference them, and later on I guess I could clean them. I'll just put a little to-do about it somewhere in here. to do. And fun is either a function name or, what do you say? Text segment variable. Const variable. You can tell by the looking at in, and it shouldn't really be proc name though, right? It should just be like name type, because it's not even a return type in the case of a const, right? We know by looking at that in name colon and a type. For now, ignore it. Okay. All right, cool. So we've got that. So now we can finally go back to the DAP debugger and go to stack frame here, where we said look up function name of frame address and set it here if found, right? So what we want to do is access our debug symbols and say get symbol by address iter frame address. If we found it, we want its name. Cute. Otherwise, we want this code here. So I suppose I could just do this. Else show the function name if available, or its address. Otherwise, I'm even considering showing the address along with the name because it's useful. But anyway, let's just see how this looks. So let's build this. All right, so let's hit F5 in here. Attach. So this is going to take a little while. I'm just going to remove my breakpoints and just let it run. So this is taking long because regex parsing is really, really slow. Plus we're in debug, so it's even slower. I'm definitely going to have to optimize this at some point. There are different things I have to do. I've profiled this. Really, most of the time is being spent trying to do regex matches. I think just that the regex library that comes with the standard library isn't good enough. I've looked it up and there are faster libraries, much faster, that are available, so I might have to use an external lib, which really sucks. Otherwise, there are other avenues. I could try to parallelize this. I can also, cache data. There's a whole bunch of stuff I could do. So these are optimizations. But yeah, it's crazy slow. Look at that. This got a lot slower than before. See if I pause, where are we? Yeah, you can see we're in the middle of doing matchers for regex. It's terrible. See, and I'm looking for label. Okay, I'll just keep running. This is definitely a problem now. I was able to wait a few seconds, but now, yeah, this is ridiculous. Okay, so there we are. So you see already we can see it says underscore main, which actually I thought it would say main, so that's kind of strange. No, actually, no, that's not strange at all. It is underscore main. No, yeah, because underscore main was the label name, and then single underscore name is the function name before it's been demangled, right? So if we just keep stepping in, very cool. We're actually seeing, nice. Very nice. If I just run and then pause somewhere. Oh, yeah. Okay. F5, F6. Okay, very cool. I mean, apart from the colon at the end there, this is very nice. So now, just to see what it would look like, what we'll do is we'll go back to my, where do I have it? Did I close? No, I didn't close it. No, I did. Huh. All right. Give me 1 second. Now, I can't believe I actually closed my Docker window. That was brilliant. So let's run mapping this here. Oh, no, that wasn't right. I can't type. Okay, so now if I do make clean, let's go modify. Okay, yeah, let's do that thing again. Apt install. What was it again? It's more utils. Just to get sponge back. Because I just want to see what it would look like once we have the demangled names. Okay, that's done. And then here in the make file, we put back this line. the C++ filth sponge line. And we do make debug equals 1. So this succeeded now. So now we should have our names all demangled. So let's see if that actually works. Of course, now we're gonna have to wait that what was it, 20 seconds? Definitely have to do something. I mean, of course, I am, I guess, not making a great. One thing that's not great about this code is that I keep trying to do regex matches. Again, starting all over. Maybe there's a way to combine some of this regex to be a bit smarter. But I mean, this is how I'd want to do it, right? Because basically now we're trying to match labels. If that doesn't work, then we try to match strings. If that doesn't work, then we try to match a dot directive. Maybe I should put the one that's more likely to match first. That might speed things up. Maybe the fact that I'm trying to match a label on every line when most likely it's going to be a string directive. So I'm wasting time doing this. I don't know. I do also wonder if in release it's significantly faster. We could definitely try it. I mean, I don't even know why I'm doing this in debug. I never really run debug when I'm iterating. I think I had a problem last time when I was trying to use debug. That's why I switched to it. I mean, I was trying to use release and it didn't, there was some breakpoint I couldn't hit, maybe in a lambda or something. Come on. Oh wait, I'm such an idiot. This is taking way too long. I need to attach my, oh geez, gotta attach my debugger. All right, now we start. That was definitely more than 30 seconds, right? So, yeah, because when I'm not attached, it's waiting to attach. So, let's try that again. You can watch me staring at my screen. Should hit it soon. This is crazy. Let's pause, just curious where we are. Main thread, call stack, yep, still in the matchers. It's this matcher, it's crazy slow. This seems a lot slower than even the last time I ran it. Maybe because now my strings are demangled, so they're more complicated. I don't know. Come on. Ah, there we go. Man, that took way too long. Hey, my main is still mangled. Why is that? Ah, but there's BIOS. Look at that. Look at that call stack. That's cool. Actually, I want to see the templates. Those are more interesting. Okay, so this will show the select screen. See, that's cool. Compute extents has 4 int refs and is const. That's nice. Oh, yeah. I gotta remove that. Let's see here. Am I dead? I'm dead. Okay, so that's cool. It took a little bit too long. I did want to try just to see if I was to move this label line down, because I'm thinking, I don't think it's gonna make a big difference. All right, let's try instead to build in release. Very curious to see how that goes. So for this to work, we're gonna have to change in here the, where is it? Here it is. So we're going to use release. We're going to switch the program to use release as well. So we want VS Code to launch that build. Okay, what's going on here? Unresolved external. Oh, actually my change for post up update call stack. Oh, I know why. Just need to generate the cache for CMake. I added that new file and I never updated the cache for the release build here. Okay, now we build. I'm going to need to reload. And if I recall, I need to reload the window twice because I don't know why, but when I change the package JSON, it only realizes that I need to reload it after I reload it. See? Well, not this. Oh, or maybe not. That looked like it worked. Let's see. I don't know, I don't trust it. Okay, it's building. All right, let's hit F5. This should launch the release version of Vectrexy. Let's see. Doesn't even tell me if this is a release version, does it? Oh, there it is. Yeah, good. So let's attach. Let's hope that, wow, holy crap, that was way faster. So really, in debug, it's completely unusable. That's crazy. Oops, shouldn't have done step out. Okay, so let's try that again. Let me remove the wait for debuggers just because I want to see it without having to attach what the time is like. And we'll try and stick to release builds for now. Okay, F5. There you go. Way faster. Try again. 5. Nice. Okay, so if we continue running, come in here, put a breakpoint, or somewhere. I wanted to see like a template here. Okay, here we see one. Text of 3, you know, we are using score text here, and score text 2 is a text with 3 as its template parameters. It's we're seeing that here on the call stack, which is nice. All right, let me try something here. We go to main.cpp. So one thing I do wonder is why main doesn't have a nicer name. I thought the demangled form would look good, but I guess not. Let me see. So there's main. Yeah, I should have picked up main like this. So what this tells me is that it's not finding the symbol. It's not finding this address, perhaps. I was about to say, wait, am I not adding it? But I am adding it, right? Yeah. I am adding. When I find that label. Oh. Maybe it's. No. Yeah, I don't know. This should work. What's the deal? When it parses this line, and we know it finds it because it adds it to here. That's why we stop at main. Oh, I know why. I know why. It's because of this line. What ends up happening is this adds a symbol for that address with the name main. Right, yeah. We need to put the name here like this. I wonder if I even have to do that. Let me see. Because we're going to hit the stabs line here. So actually I don't need that special case. We could just look for main. Because it's going to be added from this line. Right? Instead of looking for underscore main, we can just look for main. Let's build that. Can't believe how slow it is in debug. It's crazy slow. I feel like there's something else going on there. It can't just be that the regex library is that slow, right? What's going on here? 5. There we go. And we're not getting to main. Okay, I'm probably crashing. What did I do wrong? Let's see how debugging and release actually goes now. You see? Okay, I didn't find it. Let's go look. So there's main. Oh, it's because we're doing an exact match for the name. I gotta remove that colon thing at the end. All right. Anyways, I want to remove it because it's not really part of the name, right? So get the function name here. I don't know what to call this. Shrimp func name. Okay, so find the index of the colon and return name.substring if we found it. If index not equal to -1, or if it is equal to -1, just return name. Otherwise, return the substring of 0 to, I think, to index. Something like that. All right, let's try this. Actually, need some breakpoints here. Let's see. Match of 1 looks like this with a colon F2. When we trim it, there we go. Looks good. So this should work in theory. So here we're going to try and get the main symbol, and we got one. Perfect. So now, here we go, it says main. I guess I should put open close parens there. Where did I put the open close parens? Wasn't it me who's doing that? Oh, yeah. Right. Interesting. All right. Let's do this. Main's annoying. Because like it's like the only function that doesn't have, when it gets demangled, it doesn't have any parameters. Is it just because I didn't put parameters here? It really should show parens even if it takes no parameters, right? Like, okay, let's say I call a function called foo that takes no parameters and it prints just so that it's actually doing something. And we call foo like this, right? We build. We also stop our debugger. What's the problem? Oh, do I not support taking just one string? Huh, that's funny. I guess I never tried that. I should totally support that, of course. I guess in that case, not really a format anymore. Okay, let's see how this goes. Yes. As it's not a template, it is now multiply defined. It needs to be inlined. Still not happy. Oh, yeah. I gotta compile through here. Okay, that looks good. Just to be clear, make sure that it really works. All right. So now hit F5. Gotta attach my debugger. All right, so we see main here has no parens, but foo does. So I really think it's because main is treated specially. Even like, I guess when it's outputting stabs info, that's what gotta be the explanation here. Because like if we look at main.rst here, okay, so there's foo, so there's that label, and you see on that line it maps to the friendly name foo. Now of course I've demangled this name, so that's why we see that. Let's see if I don't demangle what that looks like, just to be sure. I'm trying to understand what's going on here. So let's say check this out. Okay, so let's go look for foo again. Yeah, so you see this Z23 V:(F7. Now if we compare this in here to main, whoops. Okay, so main is here. Yeah, so that's what it is. Main is really treated differently. Even the symbol for main has underscore, just a single underscore, and it already has no, like nothing here before any mangling or demangling has happened. So you know what would be interesting is to see what happens if we actually put arguments. So if I say int argc, you know, char star argv, like this, and we go and build that. Looks like it didn't change anything. Okay, let me just make sure. Okay, it's been deleted. Okay, wait, maybe we're not looking at the right thing. And go here. See? Same thing. Yeah, so there's nothing I can do for main. Main is really a special beast. Whether I add arguments or not, it doesn't care. It's always going to output that in the stabs file. So that's that, I guess. So if I really care, I guess I could do it in my code here, right? Like, not here, but the stack frame. Just like I was adding the parens for the here for the addresses, I could say, you know, if the name doesn't contain a paren, just add it here. It's either that, or I could do it while I'm parsing RSTs and have a special case for main. So maybe we can do like fix up function name rather than trim. If index not equal to -1, name will equal this. And then we can say if name, do we have like ends with and all that? No, eh? If name dot last back, there we go. So if it doesn't end in a closing, does that make sense? Okay, so build that. Good. remove this. And let's try this. Hit F5. Oh, and we're still crashing. Damn. What did I get wrong this time? Let's see, let's see, let's see. Oh, I know what I got wrong. I already know. I'm not finding the symbol main because I added parens, right? So let's go here. Yeah. What I might want to do then is maybe add the undecorated name along with the, like the unmangled and the mangled name. But anyways, because this is weird, right? Like, maybe there's a compiler out there that outputs stabs and it does put in the information. Maybe I need to do like a substring match. Anyway, for now, this should be fine. I'm so sure. I'm even going to remove this again. Okay, 5. All right, and there you have it. Main with parentheses. So much work for that. And yeah, and then we have undecorated names. So let's get those decorated again. Or I mean demangled again, not decorated. So make file, put that back, run this to remake everything. One more time. And there we go. So you can see, looks like a perfectly nice and normal call stack. Yeah, that's cool. You see, it shows that we're in the constructor, even when we're in the initialization list. That's great to see that that works. There we go, stdmax, the template instantiation of my version of stdmax anyway, for int. Very nice. So I hit F5. And then hit F6. And wherever we are, we break. There's our call stack. Still unsure if I want to keep this one here. Now that we know, I might remove this one. Okay, well, pretty happy with that, guys. It's looking pretty good. So we got the call stack showing function names correctly. That's pretty cool. So what does that mean? What's next? Once I get this all committed, we've done all this part here. So next time we're going to start working on, because right now we can just do step in, and we can do, so like F11, so step in, and we can do continue and pause. But what we can't do yet, which is super important, is step over and step out, and of course set breakpoints and all the other good stuff that comes after. But these three here are crucial for like a minimal debugger, right? As long as you can put breakpoints, you can step in, step out, step over, you've got, you know, a pretty decent debugger. Now, of course, after that, you know, watch and variables, super important to be able to actually look at values. Conditional, I don't think is super important right off the bat, so I'll move that down. But yeah, something like this. So we'll keep working on this next time, which should be Thursday, so in a couple nights. So yeah, pretty happy with that. So thanks guys for watching, and I'll see you the next time. All right, take care.